I have here with me this module that converts a 16 pin LCD to an I2c display. But what it is in reality, it is a GPIO IO pin extender. See, it converts the I2c ports into the data pins. Fascinating that this very chip that is made to be used with LCD can be used for other purposes because it is the library that is used to make it function for the LCD. What if we use the library to make it function as a simple GPIO extender? Well, we will have to make some changes in this chip, or you can simply buy a PCF 8574 based GPIO extender. So what exactly is uh, the pinout of this converter board? Let's have a look. So here is the schematic. I had this online from Proto Supplies, reverse engineered. Well, it was available on Google Images. And here you can see at the heart of this schematic, there is the PCF 8574 here. And the first three pins here, A0, A1 and A2, um, well, these are for the address selection of the PCF 8574. And here you can see the LCD header. And on the LCD header on the right side where you can see that the top three pins VCS, VDD and V0, these can be cut, and similarly the A and K pins, these can also be removed. We will then have remaining these pins, that is the SDSCL, which will be on the other side of the port, while D7, D6, D5, D4, these are already there on from the PCF 8574 to the LCD connector, while RS, RW and EN also are also there. See here. So basically RS is data pin, you can say P0, RW is P1 and EN is P2, while BL is P3. Now BL, you will see here, that does not go directly as P3 because it goes as, it is a backlight pin, so it goes to the transistor basically. So what we will do, we will have modification in the circuit to connect it directly to the pin over the DB0 that is not being used. And see that the D7, D6, D5, D4 are directly available over the point where LCD connector is attached. So I hope you are having the idea that what we need to do here is that P0, P1, P2 are available, while DB0 will be connected to the backlight digital pin. And the circuitry relating to the backlight digital pin that I have shown you, that is the resistance and the transistor, we will remove that and then connect using a piece of wire there. So that will complete our 8 digital. Back to our board here, we were just talking about this pin, the VCC, and the ground pin, the first two pins. We will simply cut these. Then comes the third pin. We will have to check what was it for. We will cut it also. And here is that transistor we were talking about, and the resistors. So I think so that the BL pin, we will have to see which one was the BL pin. We will cut the pins as we had discussed previously. Okay, from here it was like the header was like this. Okay, the VCC, the ground, VCC, etc., and the transistor side was down there at the back. So we will cut the extra pins, and let's see how we make the connection of the BL over here. Then we will use this as a simple GPIO extender. So I have cut all the extra pins and I have preserved only the 8 data pins, out of which this is 0, 1, 2, and this one is here, it is blank for the time being. We will have to connect the BLK pin here, and for that BLK pin we will have to see the sketch again. so that we know from where we have to remove the IC, or for where we have to remove the transistor, and where we have to put the jumper wire for the connection over here. Okay, so I have grabbed the idea that this second last pin here is the pin for BL, that is the data pin 4, and it goes from here to here, and it comes to this resistor from this jumper, right? So we will first remove this resistor here, and then we may also remove any other components, but first remove this resistor and see if this jumper goes anywhere else. If it does not, then we will not remove anything, but if it goes further ahead here, then we may also need to cut it from here using a cutter. Okay, I have removed this connector at the pot, and transistor has been removed. Here lies the transistor, and the resistance has been removed. And finally, here was a connecting wire that went from this resistor to the transistor here. I have cut it from here. Now I will simply connect from here to this pin here to make it a data pin number 4. So finally, here is the result. It is connected to the I2c port, and we have LEDs over here connected through a single resistor to the ground. And using the Adafruit PCF 8.8574 library, we are using the example code to blink all of the LEDs. So this is how we converted this module. Please like, subscribe and share. Thank you.